the principle of this machine is based off of the idea of constant force.
Balances the good features of both models.
No matter where you are in the movement, it's the same amount of force, the same weight behind it.
Welcome back to another episode of the BYU Tech Transfer Podcast. Today we have Kyle Chandler with us. Kyle Chandler is one of our prototyping interns in the Technology Transfer office. He's been with us for how long?
4 months,
4 months now, yeah. And so he helped us complete this prototype. It was started before he got here, but he kind of picked up all the pieces once he arrived and helped us put it together. So Kyle, do you mind telling us a little bit about yourself, your background, what you're studying, and your experience so far in the Tech Transfer office?
Sure. My name's Kyle Chandler. I'm a mechanical engineering student, major. I'm on my third semester now. Got a while to go, but it's actually a blast. I love it so much. And this job, especially at the Tech Transfer office, since I started in January, has actually been probably my favorite job ever.
Love to hear it. Yeah, and we didn't pay him to say that and said that by himself.
No, yeah, just me. No, but it's actually been so fun because I just get to mess around with stuff, and I get paid to do it. So.
Well, it's such a cool opportunity. You know, I put myself in your shoes. Like, if I was a student, what kind of job would I want to have? And it really is this job where we give you really cool technologies emerging out of BYU research. We brainstorm different ways to bring them to life. And then we basically just cut you loose and say, okay, make the best possible version of this with a very limited budget and sometimes limited time as well. So no, we appreciate you, Kyle, and what you're doing, and thanks for being our guest on the podcast today.
Of course.
So do you want to tell us a little bit about the technology as you understand it, and then maybe I'll come in and fill in some of the gaps?
Sure. So the principle of this machine is based off of the idea of constant force. Mm-hmm. And the idea is that instead of having something like a resistance band that you're using to train your muscles, where the farther you stretch, the harder it gets to stretch. Mm-hmm. This machine is designed so that no matter where you are in the movement, it's the same amount of force, the same weight behind it. So it basically models free weights without having to actually have weights that are moving.
Right, exactly. And this is a mechanism that was developed by the Compliant Mechanism and Robotics group here on campus. So we see a lot of inventions from them. There's a lot of different people in that group. And exactly what Kyle was saying is that in a typical piece of machinery for exercise. So I would kind of divide it into two classes. You have resistance, right, which is your Bowflex, resistant bands. I think there's something called the CrossFlex, and the force profile that is exhibited there, it basically goes from 0 and then it ramps up over the course of that motion to its peak value and then drops back down on the way down, right?
Exactly.
And then the flip side of that, where you would have like actual weights in the equipment. So you see these a lot more at the gym, but sometimes you'll see them in a home gym as well. So you select your weight, and that has a constant force, but the trade-off there is that if you want to have 500 pounds of resistance, you have to have 500 pounds loaded onto the machine.
Exactly.
Right? So it becomes incredibly heavy, incredibly hard to move around, potentially dangerous, right? If something were to break and fall or smash your fingers or something like that. And so this device here really is, in my opinion, the perfect marriage of those two ideas, where it is low weight, where we don't have to have 500 pounds to get 500 pounds of resistance, right? We're utilizing that resistance, but the force profile, obviously it starts at 0 as any weight, but then it shoots up to the force that you have it dialed in at, and then it keeps that force throughout the entire range of motion. So you get the benefits of as if you were lifting free weights, but then the weight savings of some of the other resistance type of machinery.
Exactly. Yeah.
Yeah. So you jumped into this project. Where was this project when you jumped in? Had we done quite a bit of the design? Were we still kind of in the middle of it? I can't remember exactly.
Yeah. So I received the project after the CAD model had been completely finished.
Okay.
And then a lot of the frame had been finished.
Gotcha.
But what the biggest things that were missing was the fiberglass pieces that bend, the flexures, and then the two engine frames in the back.
Okay.
Weren't there, and the pulley systems, they just weren't put together yet, so everything needed to be.
So you basically picked it up at a point where you had most of the CAD done, but had to fill in a couple pieces, and then did primarily the assembly and final fabrication. And how did that go? How well did we do on the CAD initially?
I would say it was pretty spot on. I think very, very little was up to interpretation, but for the most part, like yeah, it could all be assembled just by looking at the CAD.
Yeah, I remember coming in and helping you one of the days, and I feel like the tolerances were ever so slightly too tight in a couple
Agreed.
places where we ended up having to pound through a couple bolts to get things to line up correctly. So I think for version 2, we might oblong a couple holes and just do a couple little tiny tweaks to help that final assembly go a little bit cleaner. What are your thoughts?
No, exactly. Yeah, some of the things like the square tubing isn't taken into account, like the thickness of the walls weren't.
Right.
So when you tried to put a clamp on it, it just didn't fit exactly and stuff. But other than that, I mean, it assembled beautifully. Like, yeah, like you said, we had to pound some screws in just because the holes weren't drilled big enough. But aside from that, it was smooth.
And what's really cool about this piece of technology is obviously at Tech Transfer, we get all kinds of technology at all stages of development, all the way through concept or from concept through, something that is more fully developed. And this is definitely on the more fully developed side. So with the work that Kyle and some of the other interns did on the prototyping at this point, and with some of the suppliers that we used, realistically, we could give you a bill of materials, including suppliers for the metal frame, right? Including all the hardware that you see here. The only thing that you might have to figure out that we don't really have a supplier that we used on campus is the fiberglass setup, right?
Correct.
But everything else you could basically order off the shelf. Finding a fiberglass supplier should be fairly straightforward, right?
Absolutely.
And then from there, you would have a minimum viable product set up in manufacturing. Not yet optimized for mass manufacturing, I would say, right? I think there's still a little bit of work that would need to go into it there. But really, you could start selling this within a couple of weeks, right?
Oh, yeah.
I think so, right? And
That's fair.
Partnering with the right manufacturing institutions, we can make a couple introductions there.
True.
I imagine you could do it almost consignment based, right? Where they might build a couple machines for you, and then you could promote and market it. And then as you make those sales, they could package it, ship it for you. And there would be a few things like instructions, how to put together the final assembly, some things like that you would have to figure out. But those seem rather minor compared to actually having to design the machine from scratch.
Absolutely. Yeah. I think there's a few things like as I was building that I was like, oh, this might be improved upon, but it totally functions as it is. Right. And those would just be like aesthetic things or things that like maybe make it feel a little bit better. Or like, for example, putting the two railways in, like I can't make them perfect. This is my first time manufacturing something like this. And so there's a little bit of more friction and things like this where it's just like perfection and maybe like you were saying when you're making it ready for mass production that you could perfect.
Yeah, but they do really feel like refinement features, not total overhauls to anything that we've done, which is if you've ever gone through the product design process, like getting to this point is a tremendous amount of effort. And again, we didn't do it alone. We leveraged the research that was done by the Compliant Mechanisms Research Group, and we basically use that as a stepping off point. But having all of that prepped and ready for you and ready to hand off, again, it's just the time to market, the time to first dollar for this particular intellectual property coming out of the tech transfer office, coming out of BYU, is going to be much, much shorter than some of the other pieces of hardware tech that we have available.
Absolutely.
So with that in mind, there's also the status of the IP. So this is actually a granted patent. So we'll share this with Brady and have Brady maybe put a little overlay for us up on the screen of what that patent number is. But you can look it up online. It's still got several years of life yet. So, the intellectual property is granted. And in my opinion, it's fairly robust. Patents come in all different shapes and sizes. Some of them are really good. Some of them are a little bit weaker. This seems like a really robust, good patent to me. So whoever picks that up is going to have plenty of protection for the actual device, give you some time and runway to scale this up before some competition comes in the space. The one thing that it's lacking, in my opinion, is a really catchy name. So I've got a list of names here for you, Kyle. And sure. Kyle live is going to pick which one is going to be the name for all time and forever for this device. Maybe not, but his favorite at least. Okay?
Ready.
So the first one we got is Force Line. And these were all generated by ChatGPT, so I wasn't clever enough to come up with all these. But Force Line, this emphasizes the consistent force and sleek design. I like that one a little bit. We got Equiforce from Equal plus Force, highlighting constant resistance. That one's not bad either. Equiforce. Steady Flex suggests steady, reliable resistance with flexibility. Again, not bad. True Load. Not a big fan of this one. I don't know why, but it just doesn't ring very well to me. But it says mimics the feel of true weight loads like free weights. Like, I like the concept. I just don't like the name true
Sure.
load. Anyways, IsoFlex from isometric, isokinetic, flex for exercise, constraint, a play on constant and resistance. I don't know what ChatGPT was thinking here, but constraint has a lot of other, definitions behind it. So anyways, not a huge fan of that one either. Flux fit evokes motion, flux, but with consistent force. Not bad. Torque form suggests precision force output and muscle shaping. Okay. Core stant combines core and constant with the techie vibe. And then the last one is resistance. Again, I don't know how I feel about that one. Double meaning resistance plus strength. Okay. So any of those jump out to you? Should I run through all of them really quickly?
Sure.
Okay. So we got force line, equal force, steady flex, true load, IsoFlex, constraint, flux fit, torque form, core stant, resistance.
Gut instinct, I think I'd have to go with either the IsoFlex
Okay.
or the Steady Flex.
Okay. I like the IsoFlex. So that's what it's going to be called from now on.
Deal.
So if you license it, it's contingent on using. No, I'm just kidding. It's not. But I like that name, the IsoFlex. I feel like that's a good fit for it. It's easier than the constant force exercise equipment. Right?
Yeah.
I've been trying to tell people about it.
Bit
That's what I always use. It's a little wordy. So IsoFlex, I like that. I feel like a good branding and marketing campaign around that, around the features, and it really does have some standout features. The ability to have that constant force to keep the weight of the overall system down is just amazing. So, what did you learn from this process, Kyle? I mean, I assume this is one of the first times that you've run through kind of the prototyping of a technology. I guess I don't assume. I know this is one of the first projects that we gave you. So how did it go for you?
Really well. I think I learned a lot, especially like you were saying earlier about like tolerances, for example. I personally, I've like in the past, I've been the kind of person that just wants to like assemble something and like work it out as I see it. Oh, drill a hole here, line it up.
Right.
But coming from this model already being made and planned in advance, and I having to assemble it and work within those designs was, I would say, very different, but at the same time very educational. I think
Yeah.
I realized that there's a lot of benefit to having a pre-planned CAD modeled, fully designed thing
Yes.
that you're just following.
And you see the pitfalls for where any mistake was made, right?
Right.
Because from some of my other projects in the past, like what I've noticed is that when things go together correctly, it's great, right? You don't even think about it, right? Like the holes line up, in goes the bolt, and you're done. But then anything that's off by a little bit, right? And you spend an hour, re-drilling a hole or, bending things.
Welding something.
Exactly. Like it really drives home the point that a little bit of planning, a little bit of foresight and how it might go together and designing with that in mind can be worth, hours and hours of labor on the back end of trying to make things work by just kind of flying by the seat of your pants. So I think that's a great insight.
I also thought of like, I think of like NASA scientists where like you're just given like a part and you're told what to make and you make it. You don't really necessarily know how it's going to go together or what it's going to do. You're just told like what you need to make.
Right.
And I felt very much, even though I was like kind of the only person, like at least at this time working on it, I feel like I was part of a team because I was working with what someone else had made.
Right.
And so trying to make it work to that.
Yeah.
And I realized
engineering, when you're given enough information about like how this fits into the puzzle, and you don't need to see the whole thing, right? You just need to know, okay, like this is important because it's going to mate up here, and this is important because it's going to mate up here. Like, even though maybe you don't see the whole picture, it makes it very clear of what's important and I don't know, really helpful in the design process, I think.
Exactly.
Yeah. Nice. Okay. Well, I think we're going to do a quick demonstration of it. And I just had this thought, maybe a little bit different than what we had planned. But Kyle, do you mind maybe demonstrating just quickly how it works? And I'll talk through how that goes. Is that okay?
Yeah. I mean, fair warning, I'm definitely not a professional.
No, that's okay. And we don't have a ton of weight on here, so everything should be nice and smooth. But I at least want to talk through just generally what we thought some of the different exercises could be and the different configurations. And, we didn't try to reinvent the wheel here. This should line up pretty closely with a lot of the different exercises that you would see on any kind of commercial piece of equipment. All right, so Kyle's going to come up and grab the handles. While he's doing that, just quickly, we'll talk very briefly kind of how this works. So you've got these sleds here in the back that are connected to the cables. As he pulls on those cables, it flexes the fiberglass members here in the back out and away from the machine. And those are connected to these rigid members here up at the top. So as you can see here, this would be just like a normal, bicep or shoulder exercise. Pretty straightforward, pretty smooth. How does it feel, Kyle?
Great.
Pretty good. And we did throw a scale on it in our initial testing, and it's pretty close to constant force. And we don't claim to be the, perfect designers, the best designers in the world, but it turned out really, really nice. So there's some of those. If we had a chair, then he could do like some bench. I meant to bring in a bench and totally forgot today, but you could imagine him laying back using those same grips to then do some bench exercise. And then do you mind unclipping those and clipping them up at the top? And then we added some additional loops up here, knowing that you might want to do some sit down pull downs. You could do some tricep extensions. So it's pretty versatile. Again, I think there's a couple small changes that we might make, change the spacing up near the top to line up with maybe existing off the shelf hardware for like lat pull downs and different things like that. But generally, again, I think it turned out really well and is pretty close to what you would want from a finished product to take it to market. All right, so thank you for the demonstration, Kyle. That was super helpful. Any last parting thoughts from you about just the equipment, your experience in tech transfer? If you were an entrepreneur, how attractive would this be to you as a potential spin-off company from BYU?
I love this design. This is like my child. It was so cool to see it done and like that it worked.
Yeah.
I think my favorite thing about this design is probably like I don't know the word for it, like how modular it is, like how all the different things you can do to it. And I think because of that reason, I would find this like a very well prepared item for market. You could highlight any part of this machine. Its versatility, it's different, like we talked about, it's constant force. And in any way, I think it would appeal to people that are looking for something like this.
Yeah. And one thing that we didn't mention too terribly much early on was how to change the actual weight selections. Right. So you did demonstrate how you can double up the weight fairly quickly right up at the top there. You could do that at the bottom as well. And we didn't have a ton of fiberglass material made, so we just went with kind of this simple configuration. But the way that you change the weight is you have these fiberglass rods that you insert behind the members down here, and that changes the weight by discrete adjustments, right? So it might be a 5-pound adjustment, might be a 10-pound adjustment, might be a 15-pound adjustment, but very easily you basically lift it up, drop it into where it goes, add as many as you want in whatever configuration for whatever exercise that you're doing and weight profile that you'd like, and you're done. So I would say it is easier than things like the Bowflex or the Crossflex, because for those you actually have to bend the member to get it to connect. This one inserts straight, zero effort, zero time. It's a great feature and an improvement over what currently exists on the market.
Agreed.
So again, it kind of balances the good features of both model, right? Where in a weight machine, it's pretty easy to change the weight. You're just moving the pin. I would say that this is closer to the weight machine as far as ease of changing the weight than it is to the Bowflex.
Yeah, exactly.
Yeah. And then just maybe some of my last thoughts on this. Again, just to echo Kyle here, like this is a great piece of equipment, very well developed at this point. We're not going to claim that it's perfect, and not that there wouldn't be any adjustments that you need to make as you're rolling this out to customers. But again, with the designs that we have, with as far along as this is in the development, anybody could pick this up. We'll make those introductions to the manufacturers for you. We'll help you kind of get situated, as pointed in the right direction to start focusing on the sales and marketing side. And then, as Kyle mentioned, there's so many different angles that you could take as to why this could be a contender in the market. Again, marries the best features of both models, both the weight and the resistance training, into one machine that captures the best of both. I think it's a fantastic opportunity. So if you're interested, reach out to the Tech Transfer office. You can reach out to me directly. Go to BYU Tech Just search BYU Tech Transfer on Google. You should find us fairly easily. You can find my email, give me a call, stop by, whatever it is that you need to do. So thank you, Kyle, for joining us today. Really appreciate it, and appreciate all the work that you've done here. I'm going to have the prototype in our offices for the next couple of weeks. So if you'd like to come mess around with it, take a look at it, ask questions, again, reach out, and happy to show it to you and talk a little bit more about a license.
Thanks, Bennett.